Good morning. It's Tuesday. This is my first video, so hopefully it's going to all work out. We'll see how it works. We are learning today about whole numbers and fractions. In order to do this, we have to talk about equivalent fractions, which we did a couple of weeks ago. So I'm not sure because it was optional at the time. What I need you to do now is the do now. Write two equivalent fractions for 3/4. If you don't remember how to do it, we will go over it in just a moment. Please pause the video so you can work on your do now at this time. So what is an equivalent fraction? An equivalent fraction is two or more fractions that are all equal. Notice that this word has EQU and this word has EQU also. So they are equal. How do you get equivalent fractions? Good question. You can find equivalent fractions by dividing the same model in different ways. The cake Izzy's mom made already showed 1/2. So if you look at this cake right here, in fact, I'm going to draw a line around it. This cake right here, this is one whole cake. She had divided it in half because half of it has been eaten. So it's 1/2. You may have drawn lines in one of the ways below to show fourths. So you can also take a knife and you could cut this. And now we have 1/4, 1/4, 1/4, and 1/4. So how much of the cake has been eaten? 1, 2 out of 4. So I'm going to draw that over here. Sorry, just learning how to use this. So we had 1/2 to begin with. Now we have 2/4, and those are equivalent, so those are equal. Now I can get even fancier, but before I do that, notice these cakes are divided into fourths also. So it depends on how you want to divide it, as long as all the parts and pieces are equal sizes. So I'm going to take this cake and get fancy, and I'm going to divide it even more. Okay, they've got to be the same size. There we go. That one's off a little bit, but we'll pretend. So now let's see how many pieces of the cake we have left to eat. We have 1, 2, 3, 4. So we have 4 pieces left out of how many for the whole cake? 1, 2, 3, 4, 5, 6, 7, 8. So all of these fractions are equivalent. Now, we are not going to go through any more, but just imagine I could continue to divide this cake into even smaller pieces if I wanted to, right? So that is why I said it's two or more equal fractions, because they could be very, very, very tiny pieces and they still would be called equivalent fractions. Now, what if I don't want to draw a picture like this? You can also multiply or divide the numerator and the denominator by the same number to get equivalent fractions. So I'm going to show you what that looks like next. Okay, so equivalent fractions. To do it without showing you the picture, this is what you would do. Okay, so we have our fraction here. We have to multiply the numerator and the denominator by the same thing. The reason that works is if you took 2 and 2, so I'm going to write it down here, 2 over 2, or 2/2. That's not the best drawing of a 2, that's okay. That equals 1 whole. Well, we know anytime you multiply by 1, you get the same number. So if we were to do 5 times 1, that equals 5. Well, what if we do 1/2 times 1? What would we get? We would still end up getting 1/2. So we know that we can multiply, erase that. We know we can multiply by the same number on the top and the bottom because those both equal 1 whole. So anything multiplied by 1, it still gets the same thing. So here they multiplied by 2 and they got 2. 1 times 2 is 2. 2 times 2 is 4. Then they took this fraction, 2/4, and they did the same thing. Well, we could just start at 1/2 and go over here to 6. If we did that, we would have multiplied by oops, sorry, by 6. So if we multiply by 6 on the top, we also would have to multiply by 6 on the bottom. But we can also divide, which we're not going to do much of that in this lesson, but I wanted to go ahead and show that to you anyhow. So if we start with a fraction that's huge, like 40/60ths, we can, instead of multiplying, which we could still do, but the numbers will get huge, we could divide. So they chose to divide 40 divided by 10 equals 4, and 60 divided by 10 equals 6. Again, this number still equals 1 whole. So if we were to take 5 divided by 1, we still end up with the same number. So we can do that with fractions also. So now it's your turn. Find two equivalent fractions for 2/3. So pause this video, and it's your turn to work that out and shine. And we will be back in just a moment. So I'm going to pull up a video of another idea so you can see another way.
Good morning. We are working on whole numbers represented as fractions today. So you'll notice that I have written the number 3. So I have drawn 3 holes.
Where did it go?
I've written a number line.
This is another way I wanted to show you how you could take whole numbers and make them fractions. Remember that you always put the whole number over 1. Doesn't matter if it's 1,235 wholes. You would still put 1,325 over 1 to make it a fraction. So to make a whole number a fraction, you always, always, always put it over 1. So let's watch this.
Good morning. We are working on whole numbers represented as fractions today. So you'll notice that I have written the number 3. So I have drawn 3 holes. I've written a number line, created a number line that goes 1, 2, and 3. And now we're going to try to figure out what can happen to this 3. Now, you will find out today any whole number can be represented as a fraction if you put a 1 under it. So you could have 27 over 1, but then you'd have 27 boxes. You could have 9 over 1, but then you would have 9 holes, right? So we are going to find out what are some other ways we can name in fraction form this number 3 today. We'll be back.
And we had some technical difficulties because my daughter was helping, so I wanted to make sure I kept her work since she wanted to help out. So you'll just have to kind of look at your screen sideways because we weren't sure what we were doing, and I can't figure out how to turn the screen, but that is okay. You will still get the idea. Here you go.
My daughter's helping me film this, so just FYI. So we are taking what we just did, and some of you might have seen this trick before, but we're going to make it so that we see 2 more equivalent fractions for 3 over 1. Okay, 3 holes.
Hint, hint, TikTok.
So if you see, you can multiply by 3 and get 9, but what you do to the top, you do to the bottom. So 1 times 3 is 3. So 9/3 also equals 3. You can also multiply by 4, and you get 3 times 4 is 12. 1 times 4 is 4. Okay, so that's another equivalent fraction for the whole number 3. And what you can see is I did 9/3, and see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of my 3 holes.
Another example, because I happen to have these in the house, peanut butter bars. Okay, so I pulled out 3 whole packs of peanut butter bars. Well, amazingly enough, they are already divided into halves. Each whole is divided into halves. So if we were to look at this, this is 1/2, right? And this is 1/2. But altogether, it's 1 whole. And we have 3 of those. So what I've done over here is I've written out some information. We've got 3 holes. We know to write a whole number, you put 3 over 1 to get equivalent fractions. We got 6 over 2 because I have 1, 2, 3, 4, 5, 6. And each whole has two parts. So I could take this fraction and do 1 times 2 equals 2, but remember, if we do that to the bottom, we also have to do it to the top. If we do it to the denominator, we do it to the numerator. So now we have 6 over 2, also drawn in pictures here, so you can see that as well. Now, another neat thing to know about fractions is this fraction bar can mean out of. So you could say 1 out of 2 is the same as 1/2. It's also a division sign. So 6 divided by 2 equals 3 wholes. If we were doing this one, 3 divided by 1 equals 3 wholes. So that is how we can make these. What does this look like on a number line? Because we've seen pictures, but we haven't seen a number line. It's the same kind of idea. So depending on what number we want to start with. So let's say we want to do number 4, and that's what we're going to focus on, right? So what would 4 look like as a whole number in fraction form? So you would take 4 would become your numerator. Remember, to make it into a fraction, we always put it over a 1 because that makes our whole number, right? So how would we, or what would we do to make it equivalent, an equivalent fraction to represent 4 another way, right? So we can take this. I always draw my arrows. I know that that takes time and we don't always like to spend the time on it, but I still do it every time. Even as an adult, I do it. So I'm going to multiply. I can multiply by any number. Now, do I really want it to be a huge number? It doesn't matter. Depends on how good you are at multiplication, I guess. But usually we don't do it by a huge number. So I'm going to say 4 times 3. Let's do 4 times 3. Let's do 1 times 3, because whatever we do to the top numerator, we do to the bottom or the denominator. So 4 times 3 equals 12 over 3. 1 times 3 is 3. So I could also write this as 12 over 3. We could make another one. Now we could multiply this and get the same thing, or we can take the 4 and we can go all the way over here and do the same thing that we did before. But let's pick a different number instead of 3. So let's do the number 7. So now we are going to do the same thing. Oops. 4 times 7. 4 times 7 is 28 over 1 times 7, which is 7. Now to double check myself, I can take these two problems and I can divide. So 12 divided by 3 is 4. So do we get the right whole number? Absolutely. 28 divided by 7 equals 4. So we got it right both times. So you can pick different numbers. So we could do a 2 and we would work it out the same exact way. So that is how we solve for equivalent fractions. Now, it is your turn. Ready for this? Okay, remember, teacher time is today from 11 to 12. If you need more help, I will be on there to answer questions for math. Also, you need to look in your Google Slides for today for the work that you need to work on, or get the packet out for the problems to, I misspelled practice. I'll fix that in a moment. Oh well, sorry about that. I know it should say TICE for practice. And then you have a Mastery Connect to do to prove that you know what you're doing. Have a great day.